And now let's look at factoring some of these quadratics when the a value is larger than 1. So remember, the a value comes from the standard form, the ax squared plus bx plus c. And again, the more important, the a value, the term or the coefficient of the x squared. When this is bigger than 1, it definitely takes on a much bigger process. So definitely a skill that was discussed a lot, I know, with Algebra 1, and I know we discussed it a lot in your Algebra 2 class. So we're going to go through a couple examples here, and on the right, I'm going to list out, there's a couple steps involved here. So I'm going to kind of list out the steps as we go. All right, so this is the strategy that I'm going to show you today to factor these a values bigger than 1 is the box and the diamond. So this strategy is more traditional, what you probably did in your Algebra 1 class, utilizing what we've done, the diamond stuff, but now we throw in that box that I'm sure you guys remember from previous classes. All right, so here we go. So the first step is we need to draw our diamond, right? And on top of the diamond is your a times c value. Okay, in this particular case, we have a times c, which is 2 times 15. So on top of the diamond, we have a 30. On the bottom of the diamond, we have the b value, right? B being starting at the bottom. So that's one way to kind of remember that. So nothing's really changed from what we do with the a value of 1. We still need to fill in these values. So what multiplies to get 30, adds to get 13. Again, I showed you the process the other day with the a value of 1, how to kind of reason through this a little bit, but we have 10 and 3. 10 times 3 is 30, 10 plus 3 is 13. The next thing you need to do is draw the box. So we know when we're factoring that it is a 2 by 2, or we're multiplying binomial, so we need to draw a 2 by 2 box. And what happens in the box here, let's get a different color. So the two numbers that we can automatically see and we can put in the box is the ax squared term and the c term. Now, it doesn't matter where they go in the box, just as long as they are opposite of each other. Like I could have done ax squared here and c here. It really does not matter. Like I said, just make sure that they are opposite or across the diagonal from each other. So the formality, the ax squared goes first, the c goes diagonal of that. So in this case, my ax squared is 2x squared, and the c value is a 15. Right? Well, the two holes that are there, that comes from the two numbers that we just found out. So these two guys, right, if we're kind of keeping track with our steps, these two guys are just going to fill in the missing spots of our box. So we found, actually, I'm kind of messed up a little bit. These are x squareds. So remember, when we put these things in, these are x's. All right, so now that the box is complete, the last step that we need to take care of is pulling the GCF out of the box. Okay, so the last step after we've completed the box and the diamond, pull GCFs out. I'll even say out of box. All right, so we've got all these now terms that are now making up our binomial. We need to pull them out and simplify or factor, pulling those factors out like we have been doing all week. So we need to pull from 4 spots. We need to pull from these 2 rows, and we need to pull down from these 2 columns. So just like we've been doing all along, being able to find that greatest common factor. So GCF of 2x squared and 3x, looks like it's just going to be an x. The GCF, the biggest number that goes into both 10x and 15. Well, this has an x, that does not, so they don't have an x in common. 10 and 15, the GCF is a 5. And now we got to pull down out of the column. Well, the GCF of 2 and 10, 2 goes into both, and they both have an x they can give up. And lastly, they don't have a share. They don't share an x in common, so I can't pull that out. But 3 goes into 3, and 3 goes into 15. Now, along the outside of the box, this is the makeup of your now factors. This is going to be your factored form. All of these were positive, so we didn't have to deal with any of the negatives. But understand that this was a positive 5. This was a positive 3. So we can write x plus 5, and then 2x plus 3. Here are the factors that make up that quadratic. All right. I have 2 more examples for you. Like I said, you can pause, rewind, and slow that down as much as you can. But I think being able to list these steps out and be able to go kind of back through those should help you out a little bit. So I'm going to go a little faster with these things. This should not be new to us. And the steps are kind of written out for you there. All right. So factoring. I know I need a diamond. So I have a 6x squared and a negative 3 go. Oh, sorry. 6x squared times negative 3. The b value goes down. I know I'm going to need a box. The ax squared term goes in. The c value goes opposite. So what multiplies to get negative 18, but adds to get 7, negative 7. So I've got 1 and 18, 2 and 9. We have a negative 18, we gotta get to negative 7, so it looks like I'm gonna deal with a negative 9x and a positive 2x. So those 2 numbers are gonna fill in the part of the box. Now that you got the box complete, we need to pull the GCFs out. Well, pulling out of this row, 6 and 9 has a GCF of a 3, x squared and x, they have a GCF of an x. 2x and negative 3, all numbers do have a number in common. It's a 1. So when we're dealing with 2s and 3s, those are both relatively prime of each other. So the only thing that these guys are going to have in common is a 1. And now I'm going to factor out of the column. Again, 6 and 2, 2 goes into 2, and 2 goes into 6. This has an x and that has an x squared, so they both can give up an x. And then lastly, they don't have an x to sacrifice, but 3 does go into 3 and 3 goes into a 9. One thing you should pay attention to is both terms in these squares of the column here have a negative value. So since they have the negative value in common, I'm going to go ahead and pull that negative out with that. So one way to double check your work here, I know the negatives are going to get a little tricky. Go ahead and multiply these things back in, and you should end up with what terms are in the box. 1 times negative 3 is negative 3. 3 times negative 3 is negative 9. So make sure your negatives match up. Another kind of thing to kind of look out for, typically when you're dealing with negatives, the negative isn't going to go with the variable. Okay, so now notice how I have the negative with the constant here. Things just get a little, when we start solving, things just get a little bit more difficult when we pull a negative with the variable. So at all costs, if you can avoid that, make sure the negative goes with one of the constants and not with your variable there. All right, so let's go ahead and finish this out. Again, this isn't the answer. This is just kind of the formality or whatever you want to call it to help us get to the answer. So the actual factors of this quadratic are the stuff around the box. We have 3x plus 1. We have 2x minus 3. Like I said before, the sign to the left of them is going to stay with it. So again, those will be our 2 factors of our quadratic. And again, we can double check our answer. We know how to multiply these binomials. If I go ahead and distribute and simplify multiplying these binomials, you should end up right where you started. All right, one last example here. Again, I know I need my diamond. On top of the diamond, I have 3 times negative 10. And on the bottom, I have a 7x. The box. Ax squared. Oh, I have a third. That should not be a third, sorry. It should be a squared. Should be a 3x squared. Opposite of that goes the negative 10. So then what makes negative 30x squared but adds again a positive 7? Again, if you don't see it right away, that's fine. Go ahead and list out the factors. Remember, we need to multiply to get negative 30, but add to get a positive 7. So it looks like the negative is going to go with the 3. So I have a negative 3x here. I have a positive 10x here. That's what's going to fill in my box. Let's say 10x and minus 3x. All right, let's start factoring out of our box here. 3x squared and 10x is going to have an x. Negative 3x and a negative 10. Again, all numbers do have something in common. 3 is a prime numbers, and 3 doesn't go into 10, so the only thing they're going to have is a negative 1. Again, notice where I pulled out the negative. This row has a negative in common, so it just makes it easier to pull it out there. Another way to do this, instead of keep seeing the GCF, ask yourself, what times negative 1 gives you negative 3x? Should be a positive 3x. What times negative 1 gives you a negative 10? Positive 10. Again, because remember the box should match up. Negative 1 times positive 10, negative 10. X times 10 is 10x. And let's go ahead and fill in our factors, filling in our binomial. The left side here we have x minus 1, and the bottom we have 3x plus 10. Again, you can always double check your work, right? If I go ahead and distribute this out, right, x times 3x gives me 3x squared, and so forth and so on. You should simplify out to see that quadratic. There are a lot of steps. I know it's, this should be a refresher to you. I know there, like I said, I know there are a lot of steps, and sometimes it can be hard to remember. Just kind of the more examples you see, the more practice you get with this, the more it should kind of come back to you and start ringing a bell for you there.